The bash shell. In this nugget, we're going to explore the bash shell. We'll talk about customizing the bash shell to your liking by looking at environment variables, special files, and shell options, and see the role that they play in customizing the bash shell. And then we'll delve into shell scripts, and we'll take a look at some of the fundamentals of bash shell scripts so that you can read and use previously written shell scripts, and also so you can write your own. Let's get to work. I want to start out this nugget by talking about how to customize the bash shell. Now, we already know some ways to customize the bash shell. One of those ways is through setting environment variables. And we can see the current setting of environment variables by typing the env command, and I'll just pipe it through more so it doesn't scroll off the screen on us. Now, there is the settings for all the different environment variables on your system. Now, some of these environment variables are built in, and other ones can be created by you. For instance, I can say export favorite food equals sushi. All right. And now if I type the env command again, you'll see here in my list of environment variables, there's favorite food equals sushi. All right. Now, there's no system resource out there that's going to check the favorite food environment variable, in order to do its work. All right. This is just purely a joke or a game that shows you how you can set environment variables on your system. Now the favorite food environment variable is kind of silly, right? But there's other environment variables that you might want to set, like personal environment variables that you can use in your scripts. And later in this nugget, we're going to talk about shell scripting, and we'll see how to use the values of environment variables inside of a script. But let's talk more now about the built-in environment variables. Now, there's lots of built-in environment variables, and they have to do with different system functions. One of the functions is the history function. We know that if we hit the up arrow key on our keyboard, that we'll see the last commands that we executed from the command line. All right. Now, the history function is controlled by a set of history environment variables. And we can see the ones that are in use by doing this, by typing env and pipe that through a grep for hist. Now, the only history environment variable that's set right now is the hist size environment variable. And the hist size environment variable controls the size of the history file. So it's saying I can keep 1,000 entries in my history file. All right, so there's up to 1,000 commands that I can recall with the history command. Now, there's other environment variables relating to history as well, like hist control. All right, hist control is an environment variable that has a few different flags that you can set on it. One of the legal flags is ignore dupes. Now, what this is going to do is it's going to ignore successive duplicate entries in the history file so they don't sort of clutter up my history file. So let me just show you now that this environment variable has now been set. So if I do the env and pipe it through a grep for hist again, you'll see hist control equals ignore dupes. Let me just show you what this ignore dupes entry does for you. So if I use the history command, I go up and I execute this command again. Let me go up and execute it again. Let me go up and execute it one more time. Now let me use the up arrow key. You can see that the last command I executed is this env command. If I use the up arrow key once more, it jumps back to this export hist control. So all of these entries here were the exact same entry, and the ignore dupes command for the hist control environment variable said ignore those. Just keep one of those around and don't let the history file be cluttered up with these duplicate entries. All right, so that's all that setting did. If you want to see other commands or other environment variables relating to the history function, then you can just do a man page on history, search through that file for the word history, and you'll see all the different history environment variables that you can set. There's other built-in environment variables for your system as well. Things that control the mail utility, like how often should new mail be checked for, and where's your mail file. Things like that can be controlled by environment variables relating to the mail utility. Another environment variable that people like to mess with controls your system prompt here. So if I do an env here and I pipe it through a grep for PS1, you'll see an environment variable here called PS1, and this controls your primary prompt, the one that you're seeing right here. All right, so now how is this prompt controlled by this cryptic command here? Well, let me parse this for you and show you what's going on. So /u represents the user. So there's my username Perry. Then there's an @ sign, which is interpreted literally. So there's just an @ sign placed there. Then there's a /h, which represents the host name, in this case Nugget Souza. Then there's a colon, and then there's a /w, which represents the current working directory, and tilde represents my current working directory. /home/Perry, another way to represent that is with tilde. That's shorthand notation. Then there's a greater than sign, and there's also a space there that you can't see in the setting of PS1. It just disappears on the screen. But you can see, like, every time I type a command, it starts one away from that greater than sign. There's always one bit of space there for clarity, just so you can see what the command is. It doesn't all blur together. All right, so that's the setting that I use for my PS1, for my primary prompt. So if I change directories, like I go to etc sysconfig, for instance, you can see there that, my prompt has changed. Now etc sysconfig is my current working directory, so that's displayed in my prompt. Some people don't like to have the entire directory name displayed in their prompt. For instance, if I go into a network and then scripts, now, the prompt is taking up like half my screen, okay? And some people don't like that. They'd rather just display like the very last piece of the directory, and that last piece clues them in as to where they are. And if they need to know, the entire working directory, they can always do a pwd command to see exactly where they are in the system. So you can change your prompt so that it just displays this last piece of the entire directory where you're residing. Let me show you how to do that. So if I say export here, I'm going to say PS1 equals, I'm going to use double quotes because I've got characters in here that I want to display literally, like @ and colon and greater than sign. So here what I'm going to do is I'm still going to start with the user, I'm still going to do the @ I'm still going to do the host. Okay, I'm still going to put the colon in, but then instead of lowercase w, I'm going to use uppercase W. And uppercase W represents that just the last piece of the working directory will be displayed. Then I'll put the greater than sign, then I'm still going to put a space, and then I'm going to put that double quotes again. All right, so now you can see immediately as soon as I run that, my prompt has changed. Instead of saying etc sysconfig network scripts, it just says scripts. Even though I'm in the exact same working directory, right? It's just displaying sort of what's called the base name of the directory, the very last piece. If I go back to my home directory, you'll see the prompt has changed there now as well. Instead of tilde, which represents /home/Perry, it just says Perry, the last piece of that. If I go into the examples directory, now it'll just say examples. It won't say Perry examples or tilde examples or something like that. All right, so there's another setting for the prompt. There's actually probably 20 or 25 different things that you can display in your prompt. And obviously you don't want to display them all, but just depends what kind of work you do on the system, as to what kinds of things you want to display. Do you want to display the current date? Do you want to display the time? Do you want to display all sorts of things? The full host name? Do you want to display just part of the host name? Like if you use fully qualified domain names, you don't want like Nugget Souza at cbtnuggets.com or something like that. You just want to see Nugget Souza. Okay, so those are the kinds of things that you can display in your prompt. If you search in Google for PS1 prompt settings or something like that, you'll see all the different qualifiers that you can use inside your prompt. Like I was just saying, like time and date and those sorts of things. All those different settings will be listed out there on the internet in various how-tos and things like that. So the key there is searching for PS1 prompt settings. Now, one thing I want to get across is that these environment variables that I've just set at the command line, like the PS1 environment variable I changed, hist control, even favorite food equals sushi, those environment variables that I've set at the command line are part of my environment. If I type the env command, they'll all be in the list of environment variables. But I just want to show you something here. Let me type exit, and what I'm going to do is I'm going to start up a new shell. Now, one thing you can see right away when I started up this new shell is that my prompt is back to what it used to be. It has the tilde there instead of Perry. Okay, if I go to etc sysconfig, it displays the entire directory instead of just the last piece of the directory. How come that is? Well, before, when I set those environment variables at the command line, they were just part of that shell. As soon as I exited out of that shell and I started up a new shell, all those settings that I made from the command line were lost. If you want to make settings last from one shell to another, then you've got to put those commands into a special file. All right. Now, it depends on how many people you want to have access to those environment variables. It depends on how many people you want to have access to those variables as to where you put that information. Should you put that export ps1 equals blah in a system-wide place? Do you want everyone on the system to be able to have this sort of environment variable setting, or is it just for your personal account? Okay, so if we go up to the Etsy directory, up there's a file called profile in the Etsy directory. And this profile file is what controls all of the environment variable settings and things for the entire system. So things like the path and environment variables like that are set up in Etsy profile. If you want to make changes, if you want some environment variable to be set for everyone on your system, on the SUSE machine, they say you should put that in Etsy profile.local. Don't change Etsy profile. Okay, so profile.local is for your local settings, all right? So your favorite, environment variable settings, things like that. Okay, that's for global changes, Etsy profile or Etsy profile.local, as it were. All right, if you go back to your home directory, inside your home directory, there's a file here called .profile. It could also be called .bash profile. And this is where you would put your local settings for just you as a user. All right, so .profile or .bash profile is where you set user environment variables, things like your path or your prompt or your hist control, things like that would be set in .profile or .bash profile. Now there's other important files here, other special files. One of them is called .bashrc. Bashrc is where you set aliases or other user functions. Okay, they would be put into .bashrc. We're going to talk about aliases here in a minute so you can see what those are. But bashrc is another file that gets read when you start up a new shell. Okay, there's a global version of this as well, and on SUSE Linux it's called Etsy bash.bashrc. In other versions of Linux it's just called Etsy bashrc. And in the Etsy bash.bashrc file, there's a whole bunch of stuff in here. Again, these are global settings for aliases and things like that. Okay, so now that we know what these various special files are, let's learn how to set aliases, and we'll put them in our .bashrc file because that's where alias settings go. So an alias in Linux is kind of like an alternative name for some command. One of the things that gets done a lot of times in many distributions of Linux is there's a set of aliases defined for people that used to use DOS. Okay, that are coming from a DOS background. And it just helps them sort of acclimate to the Linux environment because a lot of the commands are the same. There's something to delete files, there's something to change the name of a file, there's something to change directories and things like that. But sometimes those commands are different in DOS than they are in Linux. Let's look at your .bashrc file here on my SUSE machine. Okay, and down here you'll see there's this test that's done. We'll talk about the test command in a few minutes when we start talking about shell scripting. But basically what this line of code says is test and see if there's a file out there called etsyprofile.dos. If there is a file out there called etsyprofile.dos, then basically use the alias settings that are contained in there. So let's take a look at the etsyprofile.dos file, and you'll see first of all how to set an alias, and also what this file is doing for you in terms of aliases. So the way that you set an alias is you give the name of some command like del. So in DOS this was the delete command. This is how you would remove a file. But in Linux that's not how you remove a file. You use the rm command. So if you type delete on the command line in Linux, if this profile is being used, then what will happen is this Linux command will run instead. Okay, and this Linux command is echo, which says print out to the screen, error, try the command remove minus IV. That's the closest thing to the DOS delete command. All right, the same for the DOS move command. Try the command move minus IV. That's the closest thing to it. So instead of normally what would happen if we didn't have these aliases set, if you typed del on a file and tried to delete it, it would just say error, there is no function del, sorry. All right, but here we're trying to make the errors like a little bit nicer to, help the people that were used to DOS acclimate to the Linux environment. All right, so these are nice if you're coming from a DOS background. But you can see just how easy it is to set an alias. You can just say alias, you set the name that you want that you want to type at the command line, and then you give what you the definition of that command, what you want it to do when you type that command. So you can, with aliases, you can make shortcuts and things like that. So let's quit out of here. Let's go back and actually edit our local .bashrc file, and we'll set some aliases in here. So like I said, you can set aliases for all sorts of things, like whether, and some people, I just noticed here at the very bottom of the screen, some people put all of their aliases into a file called .alias in their home directory. But you can see that the bashrc file will test to see if that .alias file exists, and if it does, then it will use the aliases in that file. You can also just put aliases directly right here. So, why do you want to type aliases? You want to save yourself some typing, or you want to put common commands in there that you use all the time, shortcut notations, things like that. One time, a friend of mine had a broken middle finger on his left hand, okay, and he had this big cast on his left hand. But he still, had to do computer work, right? So he couldn't type the D, the E, or the C on the keyboard like with his natural brain functions, okay? And so he just made a bunch of aliases that would sort of eliminate those letters for him. So he did things like he said alias exit equals quote, double quote exit. Okay, and now he didn't have to type or use his middle finger to type the E, XIT for exit. He could just type XIT. Okay, so things like that are what you can do with aliases. You can make them as useful or as silly as you want. Some people put spelling mistakes in, like if they always, miss the dot between CD dot dot, so they'll say CD dot dot equals CD dot dot. Okay, so there's another kind of alias that you can put in to compensate for your own like poor typing skills. Well, the last way that I want to talk about that you can customize your shell environment is with the use of shell options. There's a command called set that's a built-in bash shell command, and you can set options with the set command. You can also just see all the options with set -o, and this will show you all the different options that can be set and what their current value, whether they're on or off. All right, so the names of these commands don't inherently mean anything to you. You're going to have to look those up either in the man pages or on some sort of a web page that explains what all these are. For instance, like the Emacs command is on. What this means is that Emacs style line editing is on for the command line. So I can use like Control A on the command line. That takes me to the beginning of the line. I can use Control K to kill a line from the cursor onwards and things like that. So all those things are on. If I wanted to turn those off, I would say set +O Emacs, and that would turn off Emacs style command line editing. All right, so this is just one way to, again, customize your shell environment. There's also an unset command. You can use the unset command to get rid of environment variables, like in that case when I said favorite food equals sushi. If I just wanted to get rid of that environment variable, I could say unset favorite food. Okay, so set and unset are both built-in commands to the bash shell, and they have to do with, getting rid of environment variables or setting these shell options. Now let's move on and talk about shell scripting. What we're going to do for the rest of this nugget is talk about the basics of shell scripting. We'll talk about variables and conditional statements and loops and testing conditions and things like that. We'll talk about how shell scripts take input and how you execute shell scripts, okay? And the goal of this is not that you're going to be some expert shell scripting programmer after watching this nugget, but that you'll understand enough of the basics, and I'll point you to some resources where you can learn more. So just enough, I just want you to learn enough so that you can read some basic shell scripts and kind of get an understanding what they are, and take away some of the mystery of shell scripting. So I've created an examples directory here, and down in this directory there's a few shell scripts that I want to look at. So I'm going to open up my Emacs window, and here's the very first shell script. I've called it test1.sh. Anything in a shell script always has to start with this shebang line, sharp followed by an exclamation mark followed by the name of the shell that you're going to use. And all of the shell scripts that you're going to see most likely are going to be either like bin bash or bin/sh. Okay, then after that there's usually some comments explaining how the program works. So if you're looking for a particular shell script out on the internet, hopefully there's some kind of a description saying, oh, this is what the shell script does. When you open up the shell script and you actually look at the code, up at the top there should be a series of comments that explain how to use the program and what it does. You shouldn't have to go through and read the code line by line to really understand it if it's commented well. So everything that starts with a sharp sign here, except for that very first line, is what we call a comment, and that's ignored by the interpreter. So the interpreter, the computer in some sense, just ignores all the comments and just looks at the code. Us humans like to look at the comments to make sense of things, right? Okay, so what does this shell script do? Well, this is a really simple shell script, and all it's going to do is list all the files in a particular directory that start with an extension that you give it. Okay, so $1 here is a special kind of variable, and that is the first parameter that's passed to the program. All right, so I'm going to list all the files in a directory. I'm going to pipe that output through less, and $1 is going to be something like txt or .exe or whatever. Okay, some extension, and I'm just going to list the files of that extension. All right, so let's close this Emacs window for a minute. And in this directory here, you'll see I've just got a bunch of sh files here. And what I'm going to do is I'm going to say to execute test1.sh, the first thing I have to do is I have to make it executable. One way to make scripts executable is to use the using the short version of ChangeMod here, just using the numerical version 755. That will make this particular program read, write, and execute by the user, readable and executable by both the group and the owner. Okay, so if I say test1.sh, now I've made it executable. Now I can actually run test1.sh like so. So I can just say /test1.sh, and then I can give some file extension like sh. Okay, and there it did a long listing of all the files in this directory that had an extension of .sh. Okay, if I ran it again and I said .txt, well, there is no txt file, so the output is empty. Okay, if I copied a txt file from up above, sports1.txt, and I copy that here and I do a listing, you can see sports1.txt is in here now. And if I go back and run test1.sh with the txt parameter, then you can see I do a long listing of sports1.txt. Okay, so that's a really, really basic shell script, one line of code. Basically, the simplest kinds of shell scripts are just composed of lines of code like you would type at the Linux command line. All right, that's the most basic form of a shell script. You could put 7 lines of code in here. If there's a task that you find yourself doing repeatedly, and you type this command, then this one, then this one, then that one, then the other one, you can just write those set of commands in a shell script, and then just run the shell script to save you from typing one command after the other, after the other, after the other. Okay, that's one use of a shell script. So the next shell script I want to look at is called test2.sh. And this shell script, I'm just using some variables in here just to show you how to use variables inside of shell scripts. And we're also going to talk a little bit about quoting here and the importance of quotes and single quotes and back quotes and all this stuff inside of a shell script. Okay, so this shell script just shows how to use variables that are internal to the shell script and also environment variables. So here's a variable internal to my shell script, count equals 1. And I can do things with this. I can, use it to add stuff up and things like that, and we'll do stuff like that later. Okay, then the echo command is just a print statement. It just prints something out to the screen. Then in this echo statement, what I'm going to do is I'm going to say, hello $user, today's date and time is backtick date, end backtick, end double quotes. Okay, so what's going on in this echo statement? It says, hello $user. What's $user? Let me go back out to the shell for a second and do an env and pipe it through a grep for user. Okay, you can see here my user environment variable is set to Perry. All right, so the user environment variable is set to Perry, and then that's what's going to be printed out here. When I put a $sign in front of a variable name, that retrieves the value of the variable and substitutes it in here. Okay, so it says what it will end up printing out will be hello Perry, today's date and time is date. All right, well now if I didn't have the back tick, okay, so notice this is a back quote. It's not a single quote that's over by the enter key. It's a back quote that's usually up in the upper left-hand corner of your keyboard, okay? And this backtick says run the command that's inside of the backticks. All right, so what's going to happen here is it's going to say hello Perry. It goes and retrieves the value of the environment variable user, and then it's going to print out, today's date and time is whatever the date command would return right then. So it will execute that command and substitute it into this echo statement. The other print statement that's in this script says the value of count is $count. Okay, so here you can see I've used the word count here. But this count doesn't refer to the variable, okay? This is just the word count. When I put a $sign in front of count, that says go get the value of the variable count and stick that into this echo statement. Okay, so let's go back out to the shell and run this. First, we're going to do a change mod 755 on test2.sh, and then we're going to run test2. All right, so I hit enter here, and it says, hello Perry, today's date and time is blah, and then it says the value of count is 1. So you can see for $user, the name Perry got substituted because the user environment variable was set equal to Perry. Okay, and then the value of the date here got substituted into the echo statement because I enclosed date and backticks in the program. And then the value of count is 1, and that was the current value of that variable count in that shell script. Now, another thing that happens all the time in shell scripts is there's some sort of testing that gets done. Some condition gets tested. Let's take a look at the bashrc file that we were talking about just a little while ago. And down at the bottom of the bashrc file, there was a test. Okay, this test was testing for the existence of an alias file, a .alias file in your home directory. And the -s on this test qualifier here, on this test command, says test to see if the file exists and it has a size greater than 0. So there's something in the file. All right. Now, what this is going to do is, if the first part is true, if the test is true that there is a .alias file and its size is greater than 0, then the second part of this expression is going to get carried out. And the second part of the expression basically just runs that .alias file so that all of the aliases that are listed in it become active. Okay, so you'll see this a lot in shell scripts. You'll certainly see it a lot like in bashrc files or in the global etc profile or the global etc bashrc file. This kind of thing happens all the time. If you want to see all the different commands or all the different options for the test command, you should do a man page on test, and you'll see there's like 20 or 25 different options that you can perform with the test command. Now let's take a look at a slightly more complex bash shell script. And in this shell script, we start to use if and else statements. Now, what I talked about initially was, you could just put a series of commands in a bash shell script and execute them one after the other, after the other, after the other. And that's what a lot of bash shell scripts are. They're just, time savers and typing savers, and they just list out a series of commands that you always execute. But sometimes you need to make decisions in a bash shell script and execute one thing in a certain case and execute something else in some other case. And that's where if-else statements come in, and also what are called case statements. Case statements are, in some sense, just elaborate if-else statements. So what we do in an if-else statement is we test a condition. We say if, and then we give a test condition here. Now when we put this thing in square brackets, this test, this is just like running the test command on with this stuff inside. So before we learned about, well, the test command has these different flags that you can use, and you can test whether a file exists and that sort of thing. Well, -a is one of those things that a test command works with, one of the parameters. And the file that we're testing whether it exists, that's what the -a option does, says we're testing the existence of the /etc shadow file. If this comes back as true, like the etc shadow file does exist, then we execute this statement right here. We echo out to the screen, the password shadow file exists. All right. Else, so if it doesn't exist, if this statement is false, we skip all this stuff, and then we go down to the else and we execute the else statement, and there it says echo out to the screen, the password shadow file does not exist. All right, so this if-else statement is basically one or the other. Either something's going to, either the file exists or it doesn't exist. If it does exist, the first thing gets executed. If it doesn't exist, the second thing gets executed. Okay, now let's look at a slightly more complex code segment. Let me get rid of this panel at the bottom so we can see more of this at one time. So this code segment, we're going to do a little bit of mathematics, and we're also going to do a little bit more complex if statement. And we're also going to learn a little bit more about variables. So here we've got our variable count, and we set it equal to 5. And now what I'm going to do is I'm going to do some arithmetic. I want to store the value of count plus 3, which is 8, into a variable called new count. And to do that in bash shell scripting, you have to use the command let. So I'm saying let new count equal $count plus 3. Why do I have to use the $sign there? Because I want to retrieve the value of the variable count. And if I want the value of some variable, I have to preface it with a $sign. So 5 plus 3 is 8. I set that equal to new count. That's what the let command does. Now I've set new count equal to 8, the count is equal to 5, and then I've set up this if then else statement. Okay, now this one is a little bit more complex than the last one we saw. The last one we saw, if we scroll up, it just had an if clause, and if that was true, we did one thing, otherwise we did something else. This statement is a little bit more complex. It has a test. It says if $new count minus GT $count. What does this mean? This says if the value of new count, I'm talking about the value of new count because I put a $sign in front of it, is greater than the value of count, then do this thing. Okay, that's one possibility. A number is greater than some other number. Another possibility is else if, elif stands for else if, $new count is less than count, then do this stuff. Okay, just this line right here. All right, and if it's not either of those things, then what else is the case? There's only one case left. If something's not greater than a number and it's not less than a number, what's left? Well, then there's just this else condition, so then new count is equal to count. So basically, this is just like the if-else statement above, except there's 3 possible outcomes for this decision. The new count is greater than count, new count is less than count, or new count is equal to count. All right, and that's what's going on in the flow of control here. There's lots of different operators here, just like those test operators that we learned. You can go and look up all the different operators you can use here. GE is greater than or equal, and there's all different operators there to operate on numbers. Make sure you get your spacing right here, that there's a space in here between each of these things and the square brackets. You've got to use square brackets. You can't use parentheses. Things like that are very specific, and you've got to follow the syntax of shell scripts in order for the shell script to be carried out correctly. Okay, so what do we expect to happen here? In this particular case, it should come out and say new count is bigger than count, right? Because new count is 8 and count is 5. Up here, it should say the password shadow file does exist because we know that file exists from previous lectures. One last shell script that I want to look at is just a shell script that introduces one more concept and or a couple more concepts, and it's just a silly game that we're going to play in this shell script. Basically, what we're going to do is we're going to create a quote-unquote random number, and then we're going to have the user guess that number, and the number is going to lie between 1 and 10. So this first line of code here says what the secret number is going to be. And basically what it does is it uses the date command. Notice the date command is enclosed in backticks so that it prints out, it uses the actual value from the current date and time. And it prints it out in numerical format. So it gets rid of Thursday and October and things like that. And it just prints it out as one big long number. And then it pairs this number down so that the number lies between 1 and 10. Don't worry too much about all the details here. But basically what I've done here is I've created a number that's somewhat random based on the time of the day and puts that number between 1 and 10 into the variable called secret. Then I create this variable called guess and I set it equal to -1 to start with. Then I print out to the screen and say, I'm thinking of a number between 1 and 10. Please guess what it is. And then I start what's called a while loop here. Let me close this panel so we can see a little bit more of the program at once. So this while loop is one kind of looping structure in Bash shell scripting language. Another one is a for loop. Okay, a while loop, basically everything inside of the between do and done will be repeated over and over and over again as long as this condition is true. So while this condition is true, do all this stuff. Okay, so what is the condition? The condition says while the variable guess is not equal to the variable secret. So there, we've learned a new test operator. Exclamation equal is not equal. So while the guess is not equal to the secret number, come into the loop. Well, what is the guess? Initially, it's -1, and the secret number is some number between 1 and 10. So initially, I'm going to guarantee you that the guess is not equal to the secret number, so we'll come into this loop and execute it at least once. Then what we do when we first get in the loop is we read guess. Read is a way that you can get input into a Bash shell script. So the user is going to sit there, the script is basically going to pause at this point, and the cursor is going to flash, and the user is going to have to input a number. Now, there's no error checking done in this shell script. For a really robust shell script, for something that's actually important, you should do some error checking. Like if the user inputs the letter A or something, you shouldn't accept that. You should only accept numbers between 1 and 10. Okay, but I'm not going to worry about that. I'll just assume the user's following directions for this example. So once I read the user's input for the guess, then I do some if statements to determine if they were correct or if the secret number is bigger or smaller than their guess. So initially I say if $guess is equal to secret, then say yes, you are correct, secret was the secret number. All right. Otherwise, if the guess is greater than secret, then print out to the screen, no, the secret number is smaller, please guess again. Otherwise, it's going to print out to the screen, the secret number is larger, please guess again. So one of these three things has to be true. It has to be equal, greater than, or less than, and we'll print out a corresponding message to the screen in all the cases. What's going to happen after it executes this if statement? Well, what's going to happen is it's going to come back up to the top of the loop, and it's going to evaluate this expression again. Is guess not equal to secret? Well, if they didn't guess it correctly, then guess is not equal to secret, and we'll do the loop all over again. And we'll come in, we'll read a new guess, and then once we read the new guess, then we'll evaluate whether it's equal, bigger than, or less than. All right, and that's basically the way this is going to work. So this loop is going to keep repeating. We're going to keep reading a guess and testing whether it's equal, bigger, or smaller, as long as they haven't made the right guess. As soon as guess is equal to secret, then this condition will fail. I'll say while $guess is not equal to secret, nope, guess is equal to secret. At that point, I'll bail out of the loop. Okay, so let me go out to the shell now and actually run this program. So I've already made it executable, so I'll just /test3sh. I'm going to run the program, thinking of a number between 1 and 10, 6. Secret number's larger, try again, I'll guess 9. Secret number's larger, there's only one thing left, right? 10. You're correct, 10 was the secret number. Okay, so there's a silly little game. It explains some basics of Bash shell scripting. If you want to learn more about Bash shell scripting, go to the Google Linux search and search for basic shell scripting. And there's all sorts of little tutorials out there. Some of them are very introductory, other ones are more advanced. And delve into it as much as you find interesting. Some people find shell scripting a little intimidating, okay? If that's you, then what you should do is make sure you're familiar enough with shell scripting that you can read some basic shell scripts, poke around in the system. There's shell scripts that are written for some basic administration tasks. You should also be comfortable with running shell scripts. There's plenty of shell scripts written all over the internet to do all sorts of system administration tasks, things like backups and so on. And you should be able to at least run shell scripts and you know, poke around in them to see kind of what they're doing to make sure that you understand them at least at that level. If you want to delve in and learn all about shell scripting, that's only going to help your system administration abilities in Linux, because there's a lot of places in Linux as a system administrator that you can use shell scripts to your advantage. Well, it's time to wrap up our nugget talking about the Bash shell. We started by talking about how to customize the shell to fit our needs. And so we started by talking about environment variables. And we learned some of the environment variables that are in place that affect some of the basic commands in Linux, like the history command or the environment variable that changes your prompt and how it displays on the screen. Then we started talking about some special files, and two of importance are the etc profile file. That's the system-wide place where environment variables can be set. And remember, on SUSE Linux, they preferred if you didn't mess with etc profile and instead created a file called etcprofile.local for your system-wide environment variable settings. And then there's also the user environment variable settings that can be done in the .profile or .bash profile of your home directory. Then we talked about aliases in Bash and how you can set aliases to create shortcuts and things like that for commands, make up for poor typing skills, things like that. We talked about shell options as well. And then we moved on and talked about shell scripting, and we were really just scratching the surface here. I mean, I could do a 10 video series on shell scripting and talk about all the intricacies of shell scripting and talk about functions and all the advanced concepts of shell scripting. But all we really got to in this particular nugget was learning how to run a shell script. Don't forget to make the shell script executable so that we can run it by typing / and then the name of the shell script. And then we talked about some of the fundamentals of shell scripting, things like variables, if statements, while loops. All those sorts of things are very fundamental to nearly every shell script that you'll see out there. And I hope that you got enough of an introduction to shell scripts that you'd be comfortable enough running a shell script, and also that you could poke around and read a shell script and get an idea of, you know, what basically is going on. Certainly we didn't cover enough for you to read complex shell scripts, but any sort of basic shell script you should be able to read, and you should certainly be able to create shell scripts that are very simple and execute a series of commands one after the other. Well, I hope you found this nugget informative, and thanks for watching.